In software design, coupling refers to how much one class or module depends on another. When two components communicate, the key question is, how tightly are they linked? If one part changes, does the other need to change too? Understanding coupling is crucial for building flexible and maintainable systems. In this video, we'll explore what coupling means, why it matters, and how to design your code for better flexibility. We'll start by looking at tight coupling, then see how to loosen those connections for more robust software. Coupling happens when one component relies heavily on another's specific implementation. For example, imagine an OrderService class that directly uses a MySQL database. If you ever want to switch to a different database, like PostgreSQL, you might have to rewrite parts of OrderService. The problem isn't just having a dependency, it's being tied to a particular way of doing things. This makes your code harder to change and less adaptable to new requirements. Let's look at a code example. The OrderService class has a private field of type MySQL database. When it creates an order, it calls database save. This means OrderService is tightly coupled to MySQL. If you want to use PostgreSQL instead, you can't just swap out the database. You have to change OrderService itself. This kind of dependency makes your code rigid and difficult to maintain as requirements evolve. Reduce coupling, we can introduce an abstraction. Instead of depending directly on MySQL database, OrderService can depend on a database interface. Both MySQL database and Postgres database implement this interface. Now, OrderService doesn't care which database it's using, it just knows it can call save. This approach is called loose coupling, and it makes your code much more adaptable to change. With loose coupling, OrderService now depends on the database interface, not a specific database. This means you can easily swap out MySQL for PostgreSQL or any other database that implements the interface. Your code becomes more flexible and easier to extend. The key is that OrderService only knows about the abstraction, not the details of the implementation. But who decides which database OrderService should use? The answer is not OrderService itself. Instead, a configuration or composition layer provides the actual database implementation. For example, you might create a MySQL database and pass it to OrderService when you set up your application. This keeps OrderService focused on its job without worrying about which database it's using. Loose coupling also makes testing easier. For example, you can provide a fake database implementation when testing OrderService. This means you don't need a real database to run your tests. You can check that OrderService works correctly in isolation, making your tests faster and more reliable. This is a major benefit of designing for loose coupling. Loose coupling makes your code easier to change, test, extend, and maintain. When dependencies are replaceable, you can adapt to new requirements without rewriting large parts of your system. This leads to more robust and future-proof software. Remember, the goal isn't to have zero dependencies, but to depend on abstractions rather than concrete implementations. Wrap up, coupling is all about how much your classes and modules depend on each other. Tight coupling makes code rigid and hard to change, while loose coupling, using abstractions, makes it flexible and easier to test. Remember, loose coupling doesn't mean zero dependencies. It means depending on abstractions, not concrete implementations. Aim for designs where you can change one part without breaking others, and your software will be much easier to maintain and grow.